Hello again, this is Professor Lucien, and this is lecture 18 for Safety 380, Introduction to Occupational Safety and Health. In this lecture, I'm going to talk about slip, trips, and falls. OSHA's standards that apply particularly to this hazard, it's called Subpart D, Walking Working Surfaces. So it addresses ladders, the proper design requirements for railings, for stairs, for rails on stairs, for fixed ladders, for portable ladders, for scissor lifts, all that kind of stuff you'll find in those standards. And I just want to just cover some basic tips on ladder safety as well. For this lecture, what's interesting is I was looking at the syllabus and the required readings and what I had posted on Canvas. And I didn't see anything from the book. And so I just spent the last hour skimming through both of our textbooks. There is no chapter on falls, which is odd to me because they have a chapter dedicated to ergonomics and to things that relate to to struck by, caught in, to violence, all that stuff, but nothing on falls. But it's kind of sprinkled throughout. But I did find a few sections in which I'm going to assign to you. So you see them right here on the screen. So it's 10 pages out of chapter 28 in the Admin and Programs book, and then just 6 pages from chapter 7 of the Engineering and Technology. But mostly I'm providing you with some YouTube videos to watch, people falling, and I'll talk about some stuff too. Slip, trips, and falls are the number 2 cause of workplace non-fatal injury and illness. We had covered that when we talked about the Bureau of Labor Statistics. And as you can see on the front page of the BLS website, they do address, the estimated total number of cases involving slip, trips, and falls. And then from a Liberty Mutual safety index, 3 of their top 10 are fall related. And if I was to just do the math in my head real quick, 18 and 9 is 27.8, 27 and 3, about 31.3, I think. So about 31.3% of the total amount is due to fall-related injury. And then here, 2 of the top 5 are here, which actually I believe would then make it, from a compensability perspective, add just about as costly as overexertion, though they're not as frequent. Why do falls occur? Because gravity, really, gravity and our inability to remain stable on our feet. I guess that's one way to put it. Sometimes it's distraction, sometimes it's uneven or unexpected surfaces. Not having something that we can grab onto if we do happen to lose our balance or feel that we're tripping or falling. Not using 3-point contact when we're on a ladder. Attempting to do more at a height than we should. Shifting of our center of gravity beyond the tolerances of whatever we're standing on. Whether it's a chair or a ladder or a table. There are a lot of... I'm sorry, I'm not going to talk about the funny videos. Not realizing or respecting the risk of slipping, tripping, or falling. So maybe a hidden slippery surface or a hidden tripping hazard that we don't see. As I'd indicated before, under Subpart D of the 20 CFR 1910, walking and working surfaces. And you see here, there's also safety and health topic pages on the OSHA website. I've got the standards there. I had mentioned that the book doesn't specifically. I really think they should dedicate a chapter to it, but it's not my book. Down here, I've got a sign that says caution. The parking lot may be slippery, but what you should do is make sure you're getting out there and salting and sanding and clearing pathways. Caution slippery for when you walk into a building. There should be some mats that will catch water or precipitation, could be snow or ice, before it gets onto a surface that gets very slippery. Next is a trip hazard. So attempting to identify and eliminate those just, slight changes in floor height or ground height, because that's what we can trip on. And then over on the right, putting up railings. So people have something to grab onto. So it gives them the 3-point contact I talked about with ladder use. There are also some topics relating to working from heights, and you can see I provided the standards. These are under Subpart F. because it's a little bit different when you're just expecting to be able to walk around and have no problem versus when you're working at a height. The higher you are, the more potential energy, therefore the potential greater the injury. And in many of these cases, what you have to do is have a personal fall arrest system. So a properly donned, which is to put on, properly worn harness with a lanyard that is actually connected to an anchor point that meets the minimum requirements, which is 5,000 pounds. So I've got the standards here. Another thing to remember, though, when people are working at heights is to prevent people from walking below you in case you drop something. I have had a lot of students go do internships with Mortensen and Blattner, and they go and spend an entire semester at a construction site for wind turbines. And they've done tests where if they were to drop a tool or a bolt when they're working up high, and it would go through a hard hat and through the skull of a person down below. They showed like things going through cars going all the way because it picks up so much speed at a height, and also inside the turbines, in the stem that goes up. What they do is they you climb a ladder for only so far, and then you climb they have a meshed floor, and you climb through a portal, and then you step off and you go up a different one. So they stagger these. So if somebody was to drop something or fall, it would just come to the next meshed floor and not all the way down. And that's what you'll see. There are requirements for fixed ladders that they can should only go so far and get to a platform and then shift it over. So when you see construction sites and they're working overhead, they should have, like on the bottom here on the right, a covered walkway in case something was to fall. You may have to have workers who are working up high have all their tools they're going to be using tethered to a belt. So if they were to drop it, the rope would catch it, or whatever the tether is. Another thing is, when I just started out with Minnesota OSHA, they were constructing the Mall of America in Bloomington, the monstrosity of commerce, as I like to call it. And while they were finishing off one of the rotundas that went it's basically ground floor all the way past the 4th level, a person was working on scaffolding, and they fell off the scaffolding and landed on another employee that was down below. And so it was a double fatality. One was a fall, one was a struck by falling object, that object being a person. And so the people working below are just at danger when people are working at height. Sometimes I think they forget that there's dangers working at height, but there's also dangers of people being below the people working at heights. Here are two really good, I believe I got these from OSHA. I want to think I did. That kind of lays out the basic safety requirements when operating a ladder. I mean, a ladder is a tool, and you have to use it properly. For a step ladder, you never go past a certain step, because the higher you go beyond that, the higher the center of gravity is, and the higher wherever the center of gravity is, if it deviates beyond the tolerances of the ladder itself, it's going to tip. That's the technical term. If you lean out too far, you'll fall off. Is really what it is. We call that I'm just going to give you the rules of thumb. I want you to read these, but the rules of thumb. One is 3-point contact, 2 feet, 1 hand, 2 hands, 1 foot. That's how you climb a ladder. That's how you also ascend to another level. Make sure always 3-point contact. You shouldn't, it reduces your chance of losing balance. Another is the belt buckle rule. And that is where your belt buckle would be on your waist. It should never, ever deviate beyond the rails of a ladder. Ever, ever, ever. So the 3-point contact, can you carry up something with one hand and climb a ladder safely? No, you cannot. You have to find a different way to, climb to the level in which you need to do work, and then have it either provided to you or lifted up. And then the thing is, if you're going to be working at a height and you need both hands, a ladder is not the proper tool. You should use what I have over here on the right, which is sort of a stair ladder or a scissor lift or a scaffolding, and it could be mobile or fixed. That's what you're supposed to be using. Or I didn't put in there a bucket, a cherry picker. You could use those too. If you're using an extension ladder or a straight ladder, there are some requirements for setting it up that comes naturally in the design of an A-frame ladder. And that is, it should be at a 4-to-1 angle. So for every 1 foot away from the wall, or every foot away from what would be considered plumb from the top of it, it should be 4 feet up. You don't want it to be too steep because then it's more likely to fall backwards. You don't want it to be too flat because then it's putting too much force at the bottom, the foot of the ladder, and it could slip out. You should make sure it's a level surface, that it's a stable surface, because when you're actually climbing up the ladder, you don't want the base to give, because then you're going to go down. And if you're going to use an extension ladder to either get onto a roof or another surface, it has to extend at least 36 inches beyond the surface so that the person can climb up and actually exhibit that 3-point contact as they step onto the new surface. Now, that's the way it works. At a certain height, you're supposed to tie it off so it can't move around, or at least have a person down below. You're supposed to watch out for overhead issues, for electrical issues, and make sure that the ladder is in proper operating condition. If it's damaged, take it out of service. Oh, wow. So I covered a lot, both issues and solutions, but there's a lot more to it. We're always exposed to gravity. And it's the number 2 cause of non-fatals, and actually it's the second cause of fatals as well, which again alarms me that the book doesn't have a chapter completely dedicated to it. So for the quiz, read the book, use the study sheet as preparation, and I hope you enjoy the videos. If you have any problem with the videos because the link has gone bad, because I check on them and sometimes they work for me, let me know. And I can correct those because I've got a lot of them to play with. So, get any questions, let me know.